All right, let's talk about gravity. I mean, you feel it every single second of every day, right? It's just there. But what if I told you that our entire understanding of it, that fundamental pull, is just the tip of the iceberg? We're about to dive into a seriously radical idea that reframes not just gravity, but maybe reality itself.
So, let's just put the big question on the table right away. What if gravity isn't a force at all? What if that pull we feel is actually a complete misunderstanding of something way deeper and honestly a whole lot stranger? This one question is going to be our guide as we try to unpack the very fabric of existence.
Okay, so to even begin to answer a question that big, we can't just tinker with the old ideas. We have to, tear everything down to the foundation and start totally fresh. We have to challenge our most basic assumption about what space even is and build up from a completely new first principle. And here is that fundamental shift in thinking. For centuries, we've pictured space as, an empty box, a passive stage. And matter, you, me, the planets, we're just the actors moving around inside this box. But this new view, it flips that script completely. It says space is the actor. Matter isn't in space. Matter is something that space does. So what is this active space? Well, the technical term is an oscillatory phase field. I know, it sounds a little intimidating, but stick with me. The best way to picture it is to imagine a vast, invisible drum skin that stretches across all of reality and it's constantly vibrating. That's space. It's not empty, it's a dynamic, humming, oscillating substance.
Right, so if the whole universe is just this one big vibrating thing, then what are we? What is the Earth? What are the stars? What are the atoms that build everything? Well, the answer lies in how those vibrations can behave.
Let's go back to that cosmic drum skin. The default state is for vibrations to just travel freely across it, right? A ripple goes from one end to the other, unimpeded. Well, in this model, that's what we perceive as pure massless energy. A photon of light, for example, is literally just a ripple propagating through the fabric of space.
But what if a vibration doesn't just travel freely? What happens if it folds back on itself and gets stuck? It can become phase-locked, which just means it's trapped in a stable, self-reinforcing pattern. It becomes a knot, a tiny, persistent little storm in the field that holds its own shape.
And this brings us to the absolute key insight. That tiny, stable knot of trapped vibration, that's what we perceive as a particle of matter. An electron isn't a tiny little ball of stuff. It is a piece of space that has been twisted and knotted into a stable shape. Think about that for a second. Matter isn't made from something else. Matter is what space becomes.
And this isn't just a vague metaphor. In this model, the entire zoo of fundamental particles we know about can be described by different types of these stable geometric shapes. You hear physicists throw around terms like vortices or solitons. Well, these are all examples of self-contained knots in spacetime. They aren't things in the traditional sense. They're literally trapped geometry.
Okay, so let's recap. We have a brand new picture. Space is a single vibrating field, and matter is just a collection of knots in that field. Now, with those two pieces in place, the true nature of gravity just emerges. It's a natural consequence. You don't even have to add it into the equation. It just falls out automatically.
And this is the moment it all comes together. If a planet, or a star, or you, is just a really dense region of this knotted, compressed spacetime, what effect does that have on the space around it? What, then, is gravity?
Here it is, the big reveal. Nothing is pulling anything else. When space gets all knotted up to form matter, the surrounding space is put under a kind of tension. And gravity? Gravity is simply the reaction of the surrounding space as it tries to relax and flow back toward that dense, compressed region. That's the backreaction.
Let's make that even simpler. A massive object creates a dense low point in this field of space. Other objects aren't being pulled towards it, they are simply following the natural gradient. They're sliding downhill into that denser region. It's just like the classic demonstration of a bowling ball on a rubber sheet making marbles roll towards it. There's no pull, you're just following the curve. Now thinking about gravity this way, as this kind of emergent pressure from space just trying to chill out, it has profound implications. It offers a much, much simpler and potentially more unified picture of how the whole universe works. So let's just recap the logical flow here because it's so beautifully clean. 1.
You start with the premise that space oscillates. 2. A natural consequence is that sometimes these oscillations get trapped, and that's what we call matter. And finally, 3. The space around these knots reacts to the tension, creating the backreaction that we call gravity. It's a single, unbroken chain of cause and effect.
And what's really powerful about this whole thing is that it potentially solves one of the biggest problems in all of physics. We no longer have to struggle to unify gravity with the other forces, because in this picture, gravity isn't a fundamental force at all. It's an emergent side effect. It's just a consequence of the geometry of matter itself.
So we're left with this final, provocative idea. Gravity isn't some mystical pull acting at a distance. It's the very fabric of reality put under tension by the knots we call matter, constantly trying to smooth itself out. And that really makes you wonder, doesn't it? What else might be hiding in plain sight, not as a force, but as a consequence of pure geometry?